Now, as you all probably know, the first step is to draw a geometry over which we can create mesh. Therefore, we double click on the geometry module. To draw a box in the ANSYS Design Modeler software, we click on Create, go over Primitives, and then select Box. Now, in the opposite to the first session, on the low left side of the software window in front of the diagonal Z component, we change its value to 1.5. After changing the value of diagonal Z component to 1.5, we can see a rectangular box is created. Now for the next step, we want to create a cylindrical entity inside this box. Therefore, we click on this specific surface of the box and then click on the sketching button. Now under the draw list, select for the circle and then draw a circle over that surface. To create that cylindrical entity inside our box, we need to use the extrude command. After clicking on the extrude command, on the low left side of the software window in front of the geometry, simply click on apply so that our previous sketch, which was the circular sketch, could be selected. The most important part here is the operation section, which you should select a slice material so that these two geometries, which are our box and our cylinder, could be two different entities and be separated at the same time. And of course, we changed the value of FD1 depth to 1.5 because the length of our cube was 1.5 in this direction. After we click on the generate command, if I select the volume selecting button, you can see that two different parts and entities exist here. Under the tree outline section, if you expand the parts and body section, you can also see that two different parts, which are our cylinder and our box, exist here as well. Another point worth mentioning here is that in projects where you have different bodies inside your geometry, in order to create a whole and a united body from those geometry, you can simply select all the bodies shown under the part and body section and then right click on them and then click on form a new part. But in this project, since we want to have two different bodies for our meshing and that we want to test the ANSYS meshing capabilities, we leave these two bodies separated. Now in this step, we close the ANSYS Design Modeler software and then start the ANSYS Meshing. Now as you all can probably remember, in the previous session we talked about the global settings for the mesh. Now in this session we are going to talk about the local setting and customized commands that we can use in order to create a better mesh for our geometry. You can find these local commands and settings if you right click on mesh and then go over insert. Now in this session we are going to mainly talk about the methods. Now in order to compare our initial mesh with the new meshes that we create when we make changes inside our commands and settings, we click on generate button without defining any settings. Now after creating the mesh, pay attention to the mesh cells that are created inside our cylinder and inside our box. You can see that the nodes over the meshes inside our cylinder are not interconnected with the nodes of the mesh cells that are placed and created inside the box. Now this condition happens when you have two different geometries. As you can remember, we talked about creating or not creating a whole and a united part in the Design Modeler software. When you do not create a united body, a connection happens between the two objects that are separated. For example, here you can see that the mesh cells inside the cylinder entity is different from the mesh cells that are placed over the box. This option is mainly used when you have projects in which you want to simulate mesh motion, for example. Now, the first ability of ANSYS Meshing that we are going to explain and talk about is the ability to create tetrahedron mesh inside the computational domain. To access that option or setting, you have to right click on the mesh, go over Insert, and then click on Method. After clicking on the Method command on the low left side of the software window in front of the geometry, you have to select the geometry over which you want to create, for example, your tetrahedron mesh. For example, let's say we want to create our tetrahedron mesh only over our cylinder. Therefore, we select the cylinder geometry as our geometry of interest. For the next step, if you click on the method, you can see different settings exist here. These settings and options include tetrahedron, hex dominant, sweep, multi-zone, Cartesian, layered tetrahedrons, which we will explain one by one. Now, the two most important methods for creating mesh are tetrahedrons and hex dominant. For the tetrahedrons mesh, as its name says, it creates triangular 3D mesh cells inside our geometry. While when you select the hex dominant, the software will try to create hexahedron mesh cells inside our geometry, while there may be some tetrahedrons element there as well. Now, for the first method, we are going to create tetrahedral mesh cells inside our cylinder. Therefore, in front of the method, we simply click on tetrahedrons and then click on Generate button. As was mentioned before, when we select tetrahedrons in front of the method, you can see that tetrahedral elements are created inside the cylinder geometry, while hexahedron elements are created inside the box. Now, as you select the tetrahedrons in front of the method, you can see that underneath it in front of the algorithm, two options with the names of patch conforming and patch independent will appear. If you want to first talk about the patch conforming algorithm, this algorithm is mainly based on the Delaunay method for creating mesh cells. Now, this algorithm helps us create mesh cells inside our geometry with different sizes and uneven distribution, which in turn will help us perform a more accurate simulations. Now, in order for you to see and have a better view of the mesh cells that are generated inside our computational domain, we are going to use the section plane command. As was mentioned in the previous slide, you can see that the mesh cells that are generated inside the cylinder have different sizes and uneven distribution. Even if we change the element size from the global setting and define a smaller size here, you can see that this size won't affect the uneven distribution of mesh cells inside the cylinder that much. However, when you select the patch independent option from the algorithm section, the software will create an evenly distributed mesh cells with a similar size over our geometry. Now, for example, when you select the patch independent algorithm, the software will ask you for a minimum size limit for the mesh cells that are going to be generated. For example, we entered that value equal to 5 cm, similar to the value that we've entered for the element size in the global settings. Another important point that should be mentioned is that the software will give you a warning when you create a mesh using the patch independent option. As you can see in this slide, this warning tells us about that the patch independent option will become deprecated in the future versions due to several reasons. The most important reason is that though you may think that this generated mesh using the patch independent option has a better quality comparing to the patch conforming method, you are mistaken. This type of evenly distributed mesh inside a computational domain does not work capturing some specific physics like turbulent fluid dynamics to capture the eddies and turbulent viscosities inside your domain. Because this option is going to be probably removed in the newer versions, we're not going to talk about the patch independent in the details. Therefore, it is recommended to use the patch confirming method all the time. Also, another ability that the patch confirming has is that you can create boundary layer mesh or inflation mesh inside the geometry as well.